Okay, so here in this section, we want to focus on truth tables. Now, the idea behind that is so what we have in front of us here are two statements, right? So it states if you major in math, then you will get a high paying job. And the second statement is either you don't major in math or you will get a high paying job, right? So now the question here is when are they both true, right? Now, instead of trying to kind of logically think if this happens, then that happens, then what happens with both of these statements, right? The premise of these statements here, really what we want to kind of essentially doesn't really matter what they say, right? What we have are an if then statement and an or statement. And we want to focus on those statements like for the first one, P implies Q. And then for the second one, we have not P or Q, right? So here in this case, when I say P, right, what I mean is major in math. So major in math. And then Q is going to be get a high paying job. Okay, now symbolically, what both of these statements are saying is the first one is P implies Q, right? And the second one is saying not P, right? You don't major in math, or you will get a high paying job, right? And what I'm asking is when are they both true? All right. So the idea here is here's when a truth table comes into play, right? So we want to again really strip away major math. All we will care about is when is the statement true, when is it false, right? And then how does that affect the implication and this or statement here, right? So the way we do that is we set up a truth table, right? So our truth table is going to look like this, right? So we're going to have just the statements P, Q, and in this particular case, not P. All right, and then we have our implication P implies Q, not P or not Q, and then we put those together. Nice Q and not P or not or Q, excuse me. Okay. All right. So we start off here with P, Q, and not P, right? So let's just go through the different possibilities, right? And here, true. So let's say the first one, true, true, right? True, false, right? False, true, and then false, false, right? And then not P is just going to be that when P is true, then not P is false, right? And when P is false, then that means that P is true, okay? Because we're negating P. So if we negate it to be false, then it must be true. All right, and now in terms of the implication, here P implies Q, right? So this is going to be true whenever Q is true, right? Or P is false or both, right? So here, true, the only way that this is false is when our promise P comes true and then the outcome, the implication does not. So here, true, true. Okay. All right, so now let's move on to the next one, not P or Q, right? So one of those two has to be, one of those two, not P or Q, has to be true. All right, so looking again at the columns here with Q and not P, right? So that happens everywhere except when Q is false and not P is false. So we have true, false, true, true. Okay. All right, and notice here in none of these statements have I talked about what happens when I major in math, don't major in math, anything about a job, right? It's stripping out all the context and just focusing on the statement, right? As long as it's a valid statement, right? Something that is either true or false, right? And I break it down into this truth table. Okay, so now for the next one, and so we're looking for the previous two columns, right? When are they both true? So that is, so when the first row, that is true, second row is false, third row is true, true. Okay. All right, and now we can see when this statement is true, right? So this statement is true when you don't major in math, right? Looking at, so here the first one, when you major in math and you get a high paying job, right? Or you either don't major in math and you have a high paying job. All right, and the next one here, you don't major in math, but you have a high paying job. And in the last one, it's also true when you don't major in math, then you don't have a high paying job. Okay? All right. So now we can see from our truth table when both of these statements are true. All right, now one other thing to keep in mind here, a type of statement sometimes, and we'll look at a very generic one where let's say we have in general just any statement P, right? So we have P and then not P, right? And I want to make the very general statement P or not P. Right, now if we set up a truth table here, so if P is true, not P is false, and if P is false, not P is true. So P or not P, right? So only one of those needs to be true. So here in this case, all right, well, this P is true, so that statement is true. Not P is true, so this statement is true. All right, so I bring up this type of example when our uh, our statement here that we make is always true. The truth table always yields a true value. This is an example of something that is called a tautology. All right, that a statement that will always be true. Okay, not always the case as we see up here, right? That won't happen all the time, but if it does, there's a special name for that, something we call a tautology. So logically, it is always true.